Okay, just a minute. Perfect. So we are perfectly audible and visible. Hello, my dear students. This is Ritika, your chemistry educator at the very amazing platform Unacademy. And today, as you all might be knowing, that today's session it's going to be a very important session. ये जो हमारा सेशन है हम लोग बहुत इम्पोर्टेंट चीज़ें यहाँ पर आज करने वाले हैं. हेलो समृद्धि, हाउ आर यू? तो ये जो हमारा सेशन है बेसिकली बेटा इट वुड बी अ लॉन्ग सेशन एंड इट विल बी कवरिंग ऑल योर टर्म 2 इम्पोर्टेंट टॉपिक्स, है ना. तो एज यू माइट हैव ऑलरेडी बीन नोन बाय द टाइटल दैट इट इज मैराथन फॉर टर्म 2 and this is for chemistry subject. So today we are going to discuss all the important topics which are going to occur in your term 2 examinations. I'm fine, Samruddhi, thank you so much, dear. So knowing about me, I'm Ritika, your chemistry educator. I have completed my engineering in electronics and communication and have been awarded grade A by Cambridge English USA. Now talking about our session, okay, first of all I need to share a very important information with all of you. So Unacademy Creative Corner is back. अभी you might be thinking कि ये Creative Corner क्या है, right? तो Creative Corner जो है it will be related to the extracurricular activities like for example Vedic math, music, some of your hobby classes such as art and craft or chess etc. Okay, तो ये basically आपकी hobby को promote करता है, right? So when you take this plus subscription of 12 month or above, you can get the 3-month Creative Corner subscription absolutely free, right? तो अभी आपको you can use my code. So my code is RITIKACLIVE. तो आप इस कोड को यूज कर सकते हैं and this offer it is just valid till Wednesday 28th. So kindly make sure that you enroll yourself quickly. Next is okay, so I guess yeah, okay. तो अभी हम लोग बेसिकली बात करते हैं सबसे पहले कि हम लोग आज की क्लास में करने क्या वाले, व्हाट आर द बेसिक थिंग्स दैट वी आर गोइंग टू हैव इन दिस टुडेज सेशन, है ना. तो जो हमारा टर्म 2 है केमिस्ट्री का, वी आर बेसिकली गोइंग टू हैव वन शॉर्ट रिविजन ऑन दैट. ओके, सो वी विल बी डिस्कसिंग ऑल द इम्पोर्टेंट टॉपिक्स. अभी अगर हम बात करें जो इम्पोर्टेंट टॉपिक्स है वो कौन से हैं, राइट. इफ आई टॉक अबाउट योर सिलेबस, द वेरी फर्स्ट थिंग इज मेटलर्जी. Then उसके बाद you are having study of compounds. In study of compounds हमारे पास we are having 4 parts. Okay, first is hydrogen chloride, उसके बाद it is ammonia, then it is nitric acid, and the fourth one is sulfuric acid, right? These 4 chapters are there, and then we are having organic chemistry. Okay, so 3 unit and in that those 3 units we are also having sub parts. अभी बात करते हैं अगर मेटलर्जी की. नाउ स्टूडेंट्स यू माइट बी नोइंग कि जो हमारा मेटलर्जी यूनिट है, there has been many things which are cancelled from that as per your new syllabus, right? So in the metallurgy the steps to extract the metals are not right now in your syllabus, so you can avoid that. Next is talking about organic chemistry. We do not have alcohols and carboxylic acid, right? So apart from this, everything we have to study, and we will be starting with the metallurgy unit. So as I told you, this session it is going to be a bit long session, okay? And it would be very nice if you take the notes, okay? आप लोग notes ले सकते हैं. You can go for various other things, okay? You can go for the important things or important points. You can note it down, okay? So let's start quickly. Metallurgy. अभी सबसे फर्स्ट क्वेश्चन आता है हमारे माइंड में कि मेटलर्जी का बेसिक मीनिंग क्या है ना. तो मेटलर्जी क्या होता है स्टूडेंट्स? इट इज द ब्रांच विच इज रिलेटेड टू द एक्सट्रैक्शन ऑफ मेटल्स. ओके, अभी यहाँ पर क्या इंक्लूड होता है? इट इज नॉट कि सिर्फ हम एक्सट्रैक्ट कर रहे हैं मेटल्स का एंड इट इज डन. देयर आर वेरियस प्रोसेसेस, राइट. तो उस मिनरल को लेने से लेकर कन्वर्टिंग दैट ओके द ओर, कन्वर्टिंग दैट ओर इनटू अ फिनिश्ड मेटल, all these steps that a metal undergoes, it comes under the metallurgy topic. Right. Now from metallurgy, the important questions which are asked, the first one is the difference between mineral and ore. Right, these are the two very common words which are used. तो अगर हम बात करें मिनरल और ओर की, तो बेसिकली व्हाट आर मिनरल्स? मिनरल्स जो हैं हमारे नेचुरली अकरिंग कंपाउंड्स है किसके? मेटल्स के. So it is natural compounds of metals. Okay, and ore क्या है? ore actually एक मिनरल है from which we can extract the metal. अभी सारे minerals से we cannot extract the ores, right? तो basically ore क्या होता है? ये उस टाइप के, these are those minerals from which we can extract the metals at low cost and profitably, है ना? If I talk about, let's suppose that I am having this mineral, okay? इसमें जो हमारा metal content है वो 25% है, okay? And if I talk about the cost is I can say high. ओके, तो लेट्स सपोज इसका जो एक्सट्रैक्शन का कॉस्ट है वो 100 रुपीज है और मेटल का जो कॉस्ट रहेगा वो 25 रुपीज रहेगा, तो दैट इज नॉट प्रॉफिटेबल, राइट? तो ओर्स क्या होता है? जिसमें हमें प्रॉफिटेबली मेटल जो है मिल सकता है. ओके, सो दैट इज द बेसिक डिफरेंस बिटवीन मिनरल एंड ओर. ओके, सो हाउ वी कैन डिफाइन ओर? ओर आर द मिनरल्स फ्रॉम विच मेटल्स कैन बी एक्सट्रैक्टेड एट लो कॉस्ट एंड विथ मिनिमम एफर्ट. Next, we have to go with the common ores. So हमें common ores याद करनी है of aluminium, of iron and of zinc, right? So if I talk about aluminium, the common ores of aluminium, the very first one is bauxite. Correct? अभी bauxite का एक और name है, okay? It is also known by its chemical name, which is hydrated aluminium oxide. Okay, so it is hydrated aluminium oxide, and the formula for bauxite, it is Al2O3.2H2. These formula are very important for you. Next is cryolite. So what is cryolite? It is sodium aluminium fluoride. तो बेसिकली इसमें क्या है? सोडियम, एल्यूमिनियम और फ्लोरीन प्रेजेंट है. हाउ? इट इज Na3Al(F6). ओके, सो दिस इज द फॉर्मूला ऑफ क्रायोलाइट. एंड इसके बाद हमारे पास आता है कॉरिंडम. ओके, व्हाट इज इट? इट इज एनहाइड्रस एल्यूमिनियम ऑक्साइड. Correct? What is it? It is Al2O3. Now there is a difference between corundum and bauxite. Bauxite जो है, it is hydrated aluminium oxide, right? तो उसमें जो water molecule है, that is 2H2 is present, और यहाँ पर there is no water molecule present. Okay. After that, if I talk about the ore of iron, the main ore of iron, it is hematite. Okay, it is Fe2O3. After that, we are having magnetite, which is Fe3O4. उसके बाद we are having iron pyrites, which is FeS2. Okay, अभी talking about the names. Okay, we are having two type of hematite, that is red and brown. Okay, magnetite का जो chemical name है, which it is triferric tetraoxide. Okay, and iron pyrites, the chemical name is iron disulfide. So these are the common names of the ores. उसके बाद आता है ore of zinc. So zinc, again, it has got basic three ores. First is zinc blende, okay, which is also known as zinc sulfide. तो जिंक सल्फाइड का हमारा यहाँ फॉर्मूला है ZnS. ओके, देन वी आर हैविंग जिंकसाइड. हेलो वैभव, हाउ आर यू? ओके, अभी जिंकसाइड क्या है? बेसिकली ऑक्साइड हो रहा है जिंक की. okay, which is ZnO. And third हमारी आ जाती है calamine. So can anybody tell me calamine जो है which ore is it of zinc? तो हमारी जो calamine है वो है carbonate ore. Okay, so it is zinc carbonate. ZnCO3. Okay, तो ये जो basic ores हैं that you should be remembering. Okay, you could be having the questions related to these. Okay, next is the stages involved in extraction, so that are not present in your syllabus right now. Okay, वो cancel कर दी गई है. Yes समृद्धि, it is carbonate, correct. Okay, तो वो हमारा cancel हो गया है. इसके बाद जो important topic है which is extraction of aluminium. है ना? हाय शोएब. ओके, तो एक्सट्रैक्शन. अच्छा, अभी स्टूडेंट्स लिसन टू मी. देखो, if I talk about term 2 examinations of grade 10, है ना, grade 10 जो board है, you are not going to get the direct questions, right? It might be possible कि आपको जो questions है, you know, they might be a little bit twisted, right? So what is important over here is you should be having a thorough study of the topics. Okay, so if I talk about extraction of aluminium, there are two main processes, right? Hall-Herold's and Bayer's process. So it could be asked directly also, like what is Hall-Herold's process, और आपको उसमें से कुछ important topics पर question पूछे जा सकते हैं. Okay, like what are the reactions happening at cathode, what are the reactions happening at anode, why does anode needs to be replaced continuously, or I would say frequently. Okay, so these all questions, if you want to answer, you need to have a in-depth study, right? So let us start. Aluminium, if I talk about, it is the most abundant element which is present in the Earth's crust. Okay, now if I talk about why is aluminium not occurring in the free state, can anybody tell me aluminium जो है हमारा वो free state में क्यों नहीं present है? Yes, what is the reason? Why is aluminium not available in the free state in nature? कुणाल, it reacts. yes. तो बेसिक जो हमारा रीजन है, एल्यूमिनियम जो है बड़ा ही रिएक्टिव होता है. ओके, सो द बेसिक रीजन इज, अभी ये क्वेश्चन किस तरह से पूछे जाते हैं, गिव रीजन एल्यूमिनियम डजंट अकर इन द फ्री स्टेट. तो व्हाई? बिकॉज इट इज वेरी रिएक्टिव. ओके, द फर्स्ट रीजन. अभी बात आती है कि एल्यूमिनियम को एक्सट्रैक्ट कैसे करेंगे हम. ओके, हाउ डू वी एक्सट्रैक्ट एल्यूमिनियम? तो ओवर हियर वी आर हैविंग द प्रोसेस विच इज नोन एज Bayer's process and Hall-Herold's process. So these two processes are included over here. Okay, बात करते हैं सबसे पहले Bayer's process. Now students, we know that कोई भी metal जो है it is not readily available, है ना, वो अपने ores में present होता है और उसे we need to convert it into pure metal. Okay, तो जो हमारी aluminium की main ore है, yes, what is the main ore of aluminium? Anyone? कौन सी ओर से एक्सट्रैक्ट किया जाता है एल्यूमिनियम मेजरली? हाँ जी, यस स्टूडेंट्स, व्हाट डू यू थिंक, व्हिच ओर इज यूज्ड? इट इज बॉक्साइट, करेक्ट कुणाल. तो हमारा जो एल्यूमिनियम है वी आर यूजिंग बॉक्साइट ओर. ओके, all right, and what is the common name? We have just discussed. If anyone knows it, kindly let me know in the chat box. Okay, तो हमारा जो bauxite है it is Al2O3.2H2O. अभी इस bauxite में basically 60% aluminium oxide हमें मिल जाता है. Bauxite is a common name. समृद्धि, what is the chemical name? Okay, और जो बाकी का होता है 40% it is some titanium oxide, sand and other impurities, right? अभी सबसे पहले बात आती है that what which process does it undergo. ओके तो सबसे पहले हमें इस बॉक्साइट ओर को प्योरीफाई करना होगा, राइट? वी नीड टू प्योरीफाई. सो इफ आई टॉक अबाउट प्योरिफिकेशन of bauxite ore, it is known as Bayer's process. अभी here question कैसे पूछे जाते हैं? ओके क्वेश्चन कैसे पूछे जाएंगे बच्चों? फर्स्ट ऑफ ऑल, which process is used to purify the bauxite ore? Okay, next question, what is Bayer's process? Okay, and third question, how is bauxite converted to alumina? तो 3 टाइप के क्वेश्चन है, आंसर एक ही है, राइट? सो फर्स्ट ऑफ ऑल द वेरी एसेंशियल थिंग इज आपको प्रोसेसेस के नेम यू शुड बी रिमेम्बरिंग इट बाय हार्ट. ओके पता है कि बॉक्साइट को एल्यूमिना में कैसे कन्वर्ट किया जाता है, लेकिन नेम नहीं पता है और क्वेश्चन में आ गया बेयर्स प्रोसेस समझाइए. सो हाउ यू विल बी गोइंग फॉर दैट? ओके सो काइंडली रिमेम्बर द नेम्स वेरी वेरी केयरफुली. अभी बात करते हैं बेयर्स प्रोसेस की, हाउ डज इट अंडरगो. नाउ ओवर हियर स्टूडेंट्स, सबसे पहले हम लोग क्या करेंगे, वी टेक बॉक्साइट, ओके, और उसको हम पाउडर फॉर्म में कन्वर्ट करेंगे. सो इट इज ग्राइंडेड. ओके ग्राइंड करने के बाद हम उसे हीट कर देंगे. नाउ व्हाट इज द रीजन टू हीट इट? कैन एनीबॉडी टेल मी उसे हीट क्यों किया हमने? हाँ जी, why have we heated it? तो बेसिक जो रीजन है हमारा हीट करने का वो यही है कि जो भी वोलेटाइल इम्प्योरिटीज है, राइट, वो सारी रिमूव हो जाए. ओके सो हीटेड टू रिमूव वोलेटाइल इम्प्योरिटीज. चलो after that what happens? After that we are taking it and we are again heating it under pressure. Okay, now here we are heating it with caustic soda. Okay, so what is basically happening? We have taken the bauxite. इसे हम under pressure we are heating with the caustic soda, that is sodium hydroxide. Okay, अभी हमारे पास क्या होगा? We will be having sodium meta-aluminate. Okay, so this compound, it is known as sodium meta-aluminate. Okay, now from here what is the next step? What do? We dissolve the sodium meta-aluminate in water. Okay, so what are we doing? We are taking the sodium meta-aluminate, we are dissolving it in water. अभी हमें क्या मिल रहा है? We will be getting the precipitate of aluminium hydroxide. Okay, अभी ये precipitate हमें मिला. Now what are we doing? We are filtering it. इस precipitate को हम लेकर filter करेंगे, wash करेंगे, dry करेंगे, and then we ignite it at approximately 1000 to 1100 degrees Celsius. Okay, and what do we have? We have alumina. तो अगर हमने इस precipitate को heat किया, the temperature it is approximately 1000 degrees Celsius. What do we get? We get alumina. Understood this thing everyone? Okay, अभी बात आती है इसके बाद क्या? We need aluminium, right? Not alumina. तो इसके बाद we go for the reduction process. Now reduction process के questions कैसे पूछे जाएंगे? You will be asked different type of questions that why do we go for electrolytic reduction for aluminium oxide? Anyone? Any reason for that? Aluminium oxide के लिए why do we go for electrolytic reduction? Normally क्यों नहीं reduce कर सकते by using hydrogen or carbon etc. Yes, anyone? What's the reason? Okay, तो सबसे पहले जो हमारा ये aluminium oxide है, it is very stable. This compound, it is very stable. Okay, and since it is stable, तो हम इसे easily जो है reduce नहीं कर सकते using some of the general agents like carbon monoxide or hydrogen. Okay, so we need some strong method and therefore we go for electrolytic reduction process. And what is electrolytic reduction process also known as? What's the name of this process? Electrolytic reduction of alumina. What's the name of this process? Okay, so this is named as Hall-Herold's process. Okay, kindly remember the names very properly. तो जो reduction होता है alumina का that is named as Hall-Herold's process. Okay, अभी यहाँ पर क्या हो रहा है students? Basically हमारे पास we are taking an electrolytic cell. अभी electrolytic cell क्या होता है? We are having a kind of rectangular tank. Okay, it is a iron tank और इसका जो bottom है वो थोड़ा सा slope में रहता है कुछ इस तरह से, right? And what is the reason for the sloping bottom? ताकि जो हमारा molten aluminium है वो remove हो सके. Okay, and then this tank it is lined here with a gas carbon. Okay, so whole lining of the tank it is done with the gas carbon. Okay, now we are taking the electrolyte. अभी यहाँ हमारा electrolyte क्या होता है? It is the mixture of three things. And what are those three things? We are having cryolite, okay, then molten alumina and fluorspar. Okay, तो cryolite का जो percentage है it is 60%, molten alumina it is 20% and fluorspar is 20%. Okay, तो ये जो हमारा है that is what the electrolyte. Okay, the temperature it is approximately 950 degrees Celsius and the voltage it is maintained a bit low, 5 to 6 volt. So can anybody tell me why we have maintained low voltage? What is the reason behind maintaining the low voltage? Yes, anyone? Voltage हमने low क्यों रखा है? What's the reason behind that? So basically we need low voltage to avoid the decomposition of cryolite. तो जो हमारा molten cryolite है उसका decomposition avoid करने के लिए we are going for low voltage. Okay. All right. Now talking about what are the reactions happening at cathode and anode. Okay. These could be 1 mark or 2 mark question. तो cathode जो है basically वो क्या है? हमारा inner lining है of the electrolytic cell. Okay. And what happens over here? We are getting the metal. Okay, so we are getting aluminium here. And anode, what are anode? These are the rods, the graphite rods which are suspended. Okay. Ma'am, please write the reason for low voltage. Okay, I'll just write it over here. Low voltage, it is to avoid decomposition of molten cryolite. Alright, now beep. So that is the reason. Okay, low voltage कितना maintain किया जाता है? 5 to 6 volts. So that becomes the basic reason. Okay. चलो, anode. If I talk about anode, what are we getting over here? तो हमें यहाँ पर मिलता है non-metal. Okay, always we are getting non-metal at anode. अभी one more give reason questions which give reason question is very common from this point. कि जो हमारा anode है, why do we need to replace it again and again? Ma'am, is this lecture for whole syllabus? हाँ जी, Enroll, we are going to have the whole syllabus. It has just started. अभी I guess half an hour हुआ है. We have just started with metallurgy, लेकिन अभी हम सारे topics को cover करेंगे. Okay? Yeah. So over here, यहाँ पर क्या होता है? We know that anode जो है, okay, it is the graphite rods. तो यहाँ पर जो है, यहाँ हमारे पास क्या होता है? एक oxidation हो जाता है. and it gets oxidized to carbon monoxide, carbon dioxide. Okay, so that is why जो question आता है, it will end at, I don't know Navdeep बेटा, I guess 2-3 hours minimum we need, right? तो अच्छे से revision करने में we will be needing this time. Okay, so that is why we need to replace it again and again. Okay, तो basically हम लोग important topics cover कर रहे हैं. Okay, so I guess at least 2 hours we will be needing. Okay, हाँ जी. Now next is the reasons for using things. तो हमें question कैसे आते हैं? Why? What is the use of cryolite? What is the use of powdered coke? What is the use of fluorspar? Okay, so how much time it will continue? It has just started here. अभी तो सिर्फ half an hour हुआ है. तो यहाँ पर अगर हम बात करें क्रायोलाइट की, इसका बेसिक यूज क्या होता है? Its use is to lower the temperature. It is used to lower the fusion temperature. And second use क्या है? ये conductivity को increase करता है. Okay, so it enhances conductivity. Second हमारे पास आता है fluorspar. Fluorspar also helps to enhance conductivity. And second जो है, it acts as solvent for electrolytic mixture. And next is powdered coke. अभी पाउडर्ड कोक क्या होता है? हम जो इलेक्ट्रोलाइटिक मिक्सचर होता है उस पर स्प्रिंकल करते हैं. वी जस्ट स्प्रेड इट ओवर. व्हाट इज द रीजन फॉर दैट? फर्स्ट ऑफ ऑल, इट रिड्यूसेस हीट लॉस and it avoids the burning of anode. Okay, anode burning को prevent करता है. Okay, so these are the basic things. Understood up till here? Is it clear? Next हमारे पास जो main topic है वो आता है alloys. Okay, so what are alloys, students? Anyone? What do you think are the alloys? Alloys क्या होता है basically? What do you think is meant by alloy? चलो, at this point you should be knowing what do we mean by alloy. Correct, homogeneous mixture of metals. Correct, very good. So basically alloy को हम लोग कैसे define करेंगे? It is homogeneous mixture. अब यहाँ it is not just metal, students. Okay, it can be of metals or metals and non-metals. Correct. Now talking about what is the purpose, why do we form alloys? Okay, तो purpose क्या बात करते हैं? If I talk about the reasons, okay, first of all, why do we have alloy, why do we form alloy? तो first of all उसका appearance change करने के लिए we try to change their color, we try to change their appearance. Next is उसकी chemical reactivity को change करने के लिए, right? So the reasons are, फर्स्ट ऑफ ऑल उसकी appearance को हम लोग चेंज करना चाह रहे हैं. ओके, टू चेंज द कलर और समथिंग. नेक्स्ट इज टू चेंज द केमिकल रिएक्टिविटी. इफ यू वांट समथिंग टू रिएक्ट फास्ट और टू रिएक्ट स्लो, वी कैन वी कैन गो फॉर एलॉइंग. नेक्स्ट इज मेल्टिंग एंड बॉइलिंग पॉइंट को चेंज करना है. ओके, टू रिड्यूस द मेल्टिंग पॉइंट. ओके, नेक्स्ट इज वी कैन गो फॉर एलॉइंग इफ यू वांट टू इंक्रीज द स्ट्रेंथ और इंक्रीज द हार्डनेस. ओके मैम, वो कैथोड एनोड वाले इक्वेशन फुल लिखनी है. यस, अगर आपको क्वेश्चन आता है व्हाट रिएक्शंस आर हैपनिंग एट कैथोड एंड एनोड, सो दिस इज व्हाट यू शुड बी राइटिंग. ओके नवदीप, ये तो लिखना है. ओके चलो, So these are the basic reasons कि हम लोग क्यों alloying कर रहे हैं. Okay. Next is what are the alloys that you should be learning. अभी आपको जो है you don't have to learn all the alloys. आपको basically aluminium के जो alloys है वो याद करने हैं. And how are the questions asked? I'll just tell you. Aluminium, we are having basic two alloys, duralumin and next is Magnallium. Okay. Now what you have to learn from this, you have to learn first of all their composition. The duralumin में क्या होता है? It contains 95% aluminium, then it contains copper, it contains magnesium and it contains manganese. तो ये 4 चीजें जो है combine होती है duralumin में. And what it is used for? It is used for making the bodies of aircraft. It is used to make some light tools. It is used in pressure cooker. Okay. Next is Magnallium. It contains aluminium and magnesium. Okay. So over here we are having aluminium approximately 90 to 95% and magnesium is 10 to 5%. Correct. Now what it is used for? It is also used in aircraft. It is used to make light tools. It is used to make some scientific instruments, etc. Okay, so ये जो है basic alloys you should be remembering. Okay, so here we come to the end of the metallurgy unit. Is there anything that you haven't understood from metallurgy? Yes, students. Anything that you are still confused about in the metallurgy unit? If there is anything, you can please let me know in the chat box. We'll just discuss those things. Okay. Moving on to next. Okay, thank you Anmol. अभी हमारा जो नेक्स्ट टॉपिक है वो है हाइड्रोजन क्लोराइड. अभी हाइड्रोजन क्लोराइड जो है it is coming under the category study of compounds, and we know in the study of compounds we are having basic 4 compounds: HCl, HNO3, NH3 and H2SO4. That is hydrogen chloride, ammonia, nitric acid and sulfuric acid. Okay, let's study about them one by one. तो सबसे पहले तो how are what are the points to remember in all these study of compound topics? You should be remembering their second names. Okay, जैसे कि लेवोइजर ने नेम दिया था हाइड्रोजन HCl को muriatic acid. Okay, and this name hydrochloric acid, it was given by Davy. Okay, so this is how you should be learning. Now talking about preparation. If I talk about preparation, what is it? The very first or the very common method of preparation is just हम लोग क्या लेंगे, हाइड्रोजन को ले लिया, क्लोरीन को ले लिया, both in the gaseous form और वो combine हो जाएंगे, है ना. तो यहाँ पर H2 plus Cl2 it combines to form 2HCl in the gaseous form. ये दोनों gases है, right? Now over here students, question क्या आता है? पहले तो यहाँ पर condition क्या है? हमें diffused sunlight चाहिए. और क्वेश्चन आता है गिव रीजन व्हाई डू वी नीड डिफ्यूज्ड सनलाइट. तो इन द डायरेक्ट सनलाइट ये जो रिएक्शन है बड़ा ही एक्सप्लोसिव हो जाएगा. इट वुड बी एक्सप्लोसिव रिएक्शन, करेक्ट. एंड इफ आई टॉक अबाउट डार्क तो ये रिएक्शन थोड़ा सा स्लो हो जाएगा या फिर नेग्लिजिबल रहेगा, राइट. लेकिन इफ वी आर टेकिंग सम ऑफ द कैटलिस्ट सच एज एक्टिवेटेड कार्बन, अगर हम एक्टिवेटेड कार्बन को यूज करेंगे इन दी डार्क तो ये रिएक्शन इट विल बी मूविंग फॉरवर्ड. ओके, तो ये बेसिक चीज रीजंस लिख ही जाओ प्लीज. ओके ओके ओके, ऑलराइट. सो इफ आई टॉक अबाउट डार्क, द रिएक्शन इज नेग्लिजिबल. Okay, and if I talk about sunlight, or I would say direct sunlight, the reaction is explosive. Okay, सो दिस इज द बेसिक थिंग. तो ये फर्स्ट रिएक्शन तो हमने देख लिया कि ये इस रिएक्शन को हम लोग क्या बोलते हैं, डायरेक्ट कॉम्बिनेशन. ओके, तो डायरेक्ट कॉम्बिनेशन किसका हो रहा है, हाइड्रोजन और क्लोरीन का. नेक्स्ट रिएक्शन जो है, और आई वुड से नेक्स्ट प्रिपरेशन मेथड जो है, वो है किसी भी मेटल क्लोराइड को when we are heating with concentrated sulfuric acid. Okay, हमें क्या मिलेगा, we will be getting salt plus HCl. How? Let us see. तो let's suppose मैंने यहाँ पर ले लिया सोडियम क्लोराइड. ओके, दिस इज मेटल क्लोराइड. अभी इसका रिएक्शन कर देते हैं हम H2SO4 एंड यहाँ पर इट शुड बी कंसंट्रेटेड. ओके, टेम्परेचर हम लोग रखेंगे बिलो 200 डिग्री सेल्सियस. ओके, so what are we getting? I'm getting salt, that is sodium hydrogen sulfate plus HCl in the gaseous form. Okay, so this is the second one. And यही चीज जो है laboratory preparation में भी होती है. We are using sodium chloride and sulfuric acid, and this is how the laboratory preparation of hydrogen chloride happens. Hope that this is clear. Yes everyone, यहाँ तक सब कुछ क्लियर है? Okay, now let's see the type of questions which are asked on this topic. तो the very first reason NaCl को क्यों यूज किया है? Can anybody tell me NaCl को ही क्यों यूज किया है in the laboratory preparation? What's the reason for using NaCl? तो सबसे पहले तो ये बड़ा ही easily available है, and second it is cheap. Okay, तो we are using it. Correct Anmol. Second is हमने H2SO4 यूज किया है, right? We have used sulfuric acid. यहाँ पर नाइट्रिक एसिड क्यों नहीं यूज कर लेते हम? Why not HNO3? हाँ जी, why we are not using HNO3? Come on students, अभी तो आपको ये आंसर्स बहुत अच्छे से लर्न होने चाहिए. वेरी गुड दिव्या, करेक्ट करेक्ट करेक्ट. तो ये जो हमारा नाइट्रिक एसिड है ये वोलेटाइल होता है ना? तो जो हमें HCl मिलेगा उसके साथ HNO3 के भी जो है फ्यूम्स मिल जाएंगे. ओके, तो हमें HCl जो है प्योर फॉर्म में नहीं मिलेगा, राइट? दैट इज द रीजन. ओके, नेक्स्ट बात आती है कि हमें HCl गैस जो मिली है उसे प्योर कैसे करें. So it is purified using we pass it through concentrated sulfuric acid. Okay, जिसे हम ड्राई करते हैं या प्योरीफाई करते हैं, it's one and same thing. Now next things are why we are not using calcium oxide or phosphorus pentoxide. ये दो चीजें हैं. Why don't we use these? Navdeep, you will be getting the slides on the Telegram channel, dear, है ना? तो you can go and join the Telegram channel. I'll just send you the link, okay? And you will be getting the slides over there. Correct, it will react. So not used. Why? Because react with HCl. Okay. Yes, Navdeep, I'll be giving you the links. Don't worry about that. Okay. चलो, next आता है इसे कलेक्ट कैसे किया जाए. So HCl collection. It is collected by downward delivery, or we can say upward displacement of air. अभी इस चीज का भी रीजन है. Why are we going for downward delivery or upward displacement of air? The reason is, सबसे पहले तो it is heavier than air. Okay, or water, it is not collected over water. Why? Because it is highly soluble in water. ठीक है, करेक्ट. अभी इस पर एक एक्सपेरिमेंट भी है दैट वी आर गोइंग टू सी राइट नाउ, है ना. तो सबसे पहले इसे फिनिश करते हैं. दैट एज इट इज हेवियर देन एयर. करेक्ट दिव्या, श्योर यू करेक्ट, करेक्ट करेक्ट करेक्ट. हाँ जी. अभी बात आती है कि हमें जिस जार में हमने HCl को कलेक्ट किया है, हाउ टू नो दैट इफ दैट जार इज फुल और इफ इट इज स्टिल एम्प्टी. ओके, तो लेट्स सपोज इस जार में हमने जो है HCl गैस को कलेक्ट किया है. ओके, एंड अभी यहाँ पर HCl गैस इट्स फुल. ओके, नाउ वी नो दैट दिस गैस इज कलरलेस. ओके, तो हमें कैसे पता पड़ेगा दैट इट इज फुल और नॉट. हम क्या करेंगे, वी आर गोइंग टू ब्रिंग अ रॉड, or this rod it is dipped in what? It will be dipped in ammonium hydroxide. Okay, और हमें यहाँ पर क्या मिलेंगे? If it is full, we will be getting white fumes. White fumes क्यों मिल रहे हैं? Because when HCl reacts with ammonium hydroxide, it will be giving ammonium chloride. तो इस चीज के हमें जो है dense white fumes मिल जाएंगे. Correct? Understood up till here? हाँ जी, करेक्ट दिव्या, शौर्य. ओके, चलो नेक्स्ट क्वेश्चंस जो आते हैं. मैम हेवियर लाइटर का कंसेप्ट एक बार बताओ. या ओके ओके ओके, तो हेवियर लाइटर पे एक पूरा एक्सपेरिमेंट है, हम वही देख लेते हैं, है ना. if you have seen, see I am referring right now Selena book, तो उसमें एक experiment है which is to demonstrate density. Okay, if you are referring any other book, I am sure that you might be having that also. तो कुछ इस टाइप का experiment है. This is the apparatus. Okay, alright. तो ये जो apparatus है हमारा basically इट इज टू टेस्ट की जो हमारी गैस है वो हेवियर है या लाइटर है. नवदीप, योर ऑल डाउट्स विल बी क्लियर्ड हियर. ओके, अभी व्हाट आर वी डूइंग, हमने यहाँ पर एक कैंडल ले ली. ओके, दिस कैंडल इज बर्निंग. ओके, नाउ व्हाट आर वी गोइंग टू डू, हम लोग यहाँ पर क्या कर रहे हैं, हम लोग यहाँ पर HCl गैस पास कर रहे हैं, राइट. अभी सुनो, इफ देर इज एनी हेवी थिंग, वो क्या करेगा, बॉटम पोजीशन लेगा, है ना. तो यहाँ पर HCl क्या है, इट इज हैवी. तो ये क्या करेगा, हमारा जो HCl है इट विल बी टेकिंग दिस पोजीशन. ये जो नीचे वाली जो पोजीशन है इट विल बी टेकन बाय HCl, और ये जो पोजीशन पहले एयर ने ले रखी थी, द एयर इट विल बी कमिंग आउट. ओके, एंड व्हाट चेंजेस वी विल बी सीइंग, ये जो कैंडल है इट विल एक्सटिंग्विश. कैन एनीबडी टेल मी द रीजन व्हाई दिस कैंडल एक्सटिंग्विशेस? हेलो अजय. हाँ जी, ये कैंडल क्यों एक्सटिंग्विश हो गई हमारी? एनी रीजन फॉर दैट? Lack of O2 near your answer. तो बेसिकली जो हमारी HCl गैस है ये इट इज नॉट अ सपोर्टर ऑफ कंबस्शन. करेक्ट एंड नो. तो इसीलिए जो है हमारी कैंडल एक्सटिंग्विश हो गई. अंडरस्टूड? नाउ दीज एक्सपेरिमेंट्स आर वेरी इंपॉर्टेंट. ऐसा नहीं है कि आपको डायरेक्ट एक्सपेरिमेंट पूछे ही जाएंगे, बट क्वेश्चन जरूर पूछे जा सकते हैं, right? So you should be having a thorough reading. Okay, okay, then you should be knowing about some of the general properties. Okay, कि इसका reaction क्या होता है with metals, or what happens when it reacts with ammonia. That this is a very common question. अच्छा, अभी हमारी HCl अगर ammonia के साथ react करेगी तो what it will form? Can anybody tell me? What is ammonia reacting with hydrogen chloride forms? Correct, it is ammonium chloride. अभी ये question आपको इतना easily नहीं पूछा जाएगा. You could be asked which two gases combine to form a solid. तो यहाँ पर ये जो हमारा ammonium chloride it is solid, right? So you can go for this answer that ammonia and hydrogen chloride it gives reacts to form ammonium chloride, है ना? तो यहाँ तक तो हमारा हुआ यूनिट नंबर HCl. दिस यूनिट इज डन. ओके, नेक्स्ट आता है हमारा अमोनिया. व्हाट्स द फॉर्मूला ऑफ अमोनिया? Yes everyone, what's the formula of ammonia? NH3 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 करेक्ट. तो सबसे पहले तो हमारी बात आती है कि व्हाट इज अमोनिया. ओके, एंड हाउ इज इट फॉर्म. तो अमोनिया जो है इट इज प्रेजेंट इन दी इन वेरी स्मॉल ट्रेसेस इन एयर एंड in the combined state it is formed in the found in the form of compounds ammonium chloride, ammonium sulfate etc. अभी यहाँ क्वेश्चन आता है कि जो अमोनिया के जो कंपाउंड्स है, ओके, व्हाई दे डू नॉट अकर एज मिनरल्स. अमोनियम कंपाउंड्स डू नॉट अकर एज मिनरल्स. व्हाई? Yes, anyone? Why don't we have ammonium compounds occurring as minerals? Come on, that's so easy. Correct, because they are highly soluble in water. तो वो dissolve हो जाते हैं. ओके, तो स्टूडेंट्स ये जो छोटे छोटे क्वेश्चन है डोंट इग्नोर देम, दे आर वेरी इंपॉर्टेंट. 1 मार्क का पूछ लिया, 2 मार्क का पूछ लिया, एमसीक्यू में पूछ लिया, राइट? सो दीज आर वेरी इंपॉर्टेंट. नेक्स्ट बात आती है हमारे अमोनिया के फॉर्म्स की. तो वेरी फर्स्ट इज गैसियस अमोनिया, गैस की फॉर्म में अवेलेबल है. नेक्स्ट इज लिक्विड अमोनिया. ओके, तो जब अब इस ड्राई अमोनिया या गैसियस अमोनिया को वी आर लिक्विफाइंग इट, दैट बिकम्स लिक्विड अमोनिया. नेक्स्ट इज दिस वन इज इंपॉर्टेंट, ओके, लिकर अमोनिया फोर्टिस. अभी इसका जो है सेकेंड नेम भी है, ओके, इट इज नोन एज 880 अमोनिया. ओके, सो व्हाई इट इज नोन एज 880 अमोनिया? बिकॉज इसकी जो रिलेटिव डेंसिटी है इट इज 0.880. और बेसिकली ये क्या है लिकर अमोनिया फोर्टिस? ये हमारे अमोनिया का वाटर में सैचुरेटेड सोल्यूशन. सो आई विल जस्ट राइट इट ओवर हियर. लिकर अमोनिया फोर्टिस इट इज सैचुरेटेड सोल्यूशन ऑफ अमोनिया in water. Okay, and next we are having the laboratory as laboratory reagent we are using it. Okay, अभी बात आती है how to prepare ammonia. So if I talk about ammonia preparation, it is used or it is prepared using the ammonium salt. So when we take any ammonium salt और उसका रिएक्शन हम कराएंगे किसी एल्कली से, what we will be getting salt, water and ammonia. कैसे? Let us see. Let's suppose we have taken ammonium chloride. इसका रिएक्शन हमने करा दिया कैल्शियम हाइड्रोक्साइड से. तो फर्स्ट ऑफ ऑल वी विल बी गेटिंग सॉल्ट. अच्छा, कौन सा सॉल्ट मिल रहा है हमें यहाँ? एनीवन? Which salt or what are the products that we will be getting from here? Yes, which salt are we getting? Correct, sure. It is calcium chloride plus water, that is H2O, and plus ammonia in the form of gas. Okay, तो ये products हमें मिलेंगे. And if I talk about laboratory preparation भी बिल्कुल इसी तरह होती है. We are taking the ammonium chloride and calcium hydroxide. Okay, so this is how it is prepared in laboratory also. अभी बात आती है कि हाउ डू वी ड्राई इट, या फिर जो अमोनिया गैस हमें मिल रही है उसको प्योरीफाई कैसे किया जाए. ओके, सो दिस इज ड्राइड यूजिंग कैल्शियम ऑक्साइड. ओके, if I talk about the other agents such as H2SO4 और phosphorus pentoxide और कैल्शियम क्लोराइड, इन्हें क्यों नहीं यूज कर सकते? नॉट यूज्ड बिकॉज अमोनिया रिएक्ट्स विद देम. ओके, तो हमारा जो अमोनिया है ये थोड़ा रिएक्ट कर जाता है, एंड दैट इज व्हाई वी कैन नॉट यूज दीज रिएजेंट्स. अंडरस्टूड एवरीवन? Okay, correct. Divya, ammonia it is basic in nature, dear. It is not acidic. Ammonia जो है हमारी basic nature है. Okay, अभी बात आती है हमारे collection की. So how are we collecting the ammonia gas? It is collected by downward displacement of air. अभी HCl में हमने क्या पढ़ा था? Oh, okay, Divya, that's correct. Now it is going for downward displacement of air. Why? What is the reason? Because it is lighter than air. HCl हमारा heavier था, it is lighter than air. And next is it is highly soluble in water. So why cannot be collected over water? Because it is highly soluble in water. Okay, तो ये जो है हमारा basic मैन्युफैक्चरिंग प्रिपरेशन हो गया, लैबोरेटरी प्रिपरेशन. अभी अगर हम बात करें लार्ज स्केल मैन्युफैक्चरिंग, देयर इज वन वेरी फेमस प्रोसेस. कैन एनीबॉडी टेल मी व्हाट इज इट? व्हिच प्रोसेस इज यूज्ड टू मैन्युफैक्चर अमोनिया? Haber's. Very good. Acha, now students, talking about the process, there are 3 processes in your course right now. First है हमारा अमोनिया के लिए, second है हमारा H2SO4 के लिए, and third है हमारा HNO3 के लिए, right? So NH3 के लिए हमारा Haber's process है, H2SO4 it is contact process, and HNO3 के लिए हमारा Oswald process. Okay, don't get confused. Hello Dipanshu, don't get confused among these, because ये तीनों process आपको हो सकता है पूछा जाए how is ammonia manufactured or what is Haber's process. So both of them the answer will be same. Okay, but you should be knowing the names. Okay, तो ये Haber's process जो है बड़ा ही easy process है. We need nitrogen and hydrogen in the ratio 1:3. So N2:H2 we require in the ratio 1:3. Okay. अभी बात आती है कि हमें जो है गैसेस यहाँ पर बड़े ही प्योर फॉर्म में चाहिए, लेकिन यहाँ पर कैसे मिलेगी? तो नाइट्रोजन को जो है हम प्योर फॉर्म में कैसे अवेलेबल कराएंगे? एनीवन? हाउ डू वी गेट नाइट्रोजन इन द प्योर फॉर्म? हाँ जी, एनीवन? नाइट्रोजन को प्योर फॉर्म में कैसे ऑब्टेन करेंगे? Correct. It is fractional distillation of air. Just remember the name of these processes. It could be, single or 1 mark answer. You might be asked. Okay. So fractional distillation of liquid air. तो ये तो हो गया हमारा N2 का process, nitrogen. Okay. How do we get hydrogen in the pure form? We have learned the process in the 9th grade. What is the process used to manufacture hydrogen? Yes, correct, Divya. It is Bosch process. Okay, तो यहाँ पर हमें मिल जाएगा the pure hydrogen. Okay, so these are the two processes. अभी रिएक्शन बड़ा इजी है. नाइट्रोजन हमें 1 वॉल्यूम चाहिए, हाइड्रोजन हमें 3 वॉल्यूम चाहिए, and it reacts. It is a reversible reaction, and we get what? Ammonia plus heat. अच्छा, if heat is produced, reaction कौन सा होगा? What is the name given to reactions which produces heat? Correct. So it is producing heat and therefore it is exothermic reaction. Okay. नेक्स्ट बात आती है हमारी कंडीशंस की. ओके, तो इफ आई टॉक अबाउट टेम्परेचर, इट इज मेंटेन्ड एट 450 to 500 डिग्री सेल्सियस. उसके बाद इफ आई टॉक अबाउट कैटलिस्ट, इट इज आयरन. तो हम वी आर टेकिंग फाइनली डिवाइडेड आयरन. एंड देन इफ आई टॉक अबाउट प्रमोटर, तो हमारा प्रमोटर यहां पर है मोलिब्डेनम. नाउ टेल मी स्टूडेंट्स, व्हाट इज द डिफरेंस बिटवीन दीज टू वर्ड्स? हमारा जो कैटलिस्ट है और प्रमोटर है, क्या डिफरेंस है इन दोनों के बीच? जस्ट लेट मी नो, आई जस्ट बी बैक. Yes. What is the difference between catalyst and a promoter? So these could be your, Viva questions or anything like that. What is the difference? Correct, Divya. What about others? What do you think it is used for? Anyone? Catalyst और promoter में क्या difference है? तो बेसिकली क्या होता है, जो हमारा कैटलिस्ट है, this increases or decreases the efficiency of a reaction. Okay, लेकिन जो हमारा प्रमोटर है, that enhances the efficiency of a catalyst. Okay, तो वो कैटलिस्ट पर इफेक्ट करता है. नाउ टेल मी स्टूडेंट्स, अगर हमारे किसी रिएक्शन में कैटलिस्ट प्रेजेंट नहीं है लेकिन प्रमोटर प्रेजेंट है, तो कैन इट इंक्रीज और डिक्रीज द रेट ऑफ रिएक्शन? यस और नो? Can it function only by the catalyst? I'm sorry, promoter. No, correct. Okay, so that was the basic thing about your preparation of ammonia. Okay, Abhi, if I talk about catalyst efficiency increase promoters. Okay, all right. Now, students, after that, you have to go through the physical properties of ammonia. That it is colorless, it is having a very strong and pungent smell, it is alkaline in nature. Okay, and yeah, so it is highly soluble in water, etc., etc. So ये कुछ basic properties है that you should be remembering. Okay, after that you have the next one, which is nitric acid. HNO3. Okay, now if I talk about the occurrence of nitric acid, first of all we know that acid rain, it is found in the acid rain, right? Okay, Bidan, all right, it's fine, I understood. Hanji, talking about the combined state, nitric acid, it is found in the form of Chile salpetre, which is the metallic nitrate, sodium nitrate. And then what is the common name given for potassium nitrate? Anyone? What is the name given for potassium nitrate? Nitrate. Charanjit, Anmol, Divya, correct. So it is nitrate. Okay, remember these common names. अभी बात आती है कि जो हमारा नाइट्रिक एसिड है, it is formed in atmosphere, लेकिन how is it formed? Okay, that is a very important thing. तो students, we know कि हमारा जो atmosphere है, it is having nitrogen and oxygen present in the air, right? अभी क्या होता है during lightning discharge, जो नाइट्रोजन और ऑक्सीजन प्रेजेंट है हमारे एटमॉस्फेयर में, वो क्या हो रहे हैं, दे आर कंबाइनिंग. ओके, दे आर रिएक्टिंग, और रिएक्ट करके व्हाट आर दे फॉर्मिंग, दे आर फॉर्मिंग नाइट्रिक ऑक्साइड. टेम्परेचर बड़ा हाई होना चाहिए, अप्रोक्सीमेटली 3000 डिग्री सेल्सियस. तो दिस इज माय वेरी फर्स्ट स्टेप. अभी दिस नाइट्रिक ऑक्साइड ये जो है फर्दर ऑक्सीडाइज हो जाएगी. ओके, एंड इट विल बी ऑक्सीडाइज टू व्हाट, इट विल बी ऑक्सीडाइज टू नाइट्रोजन डाइऑक्साइड. ओके, एंड दिस नाइट्रोजन डाइऑक्साइड अब क्या करेगी, जब रेन वाटर हो, यू नो, इट्स कमिंग टू द अर्थ, इट विल डिसॉल्व. और जब ये डिसॉल्व करेगा, it will be forming the nitric acid. Okay, so this is known as the formation of nitric acid in the atmosphere. Next एक बड़ा ही important term आता है in this unit, fixation of atmospheric nitrogen. हाँ जी, what do we mean by this term? Anyone? What is fixation of atmospheric nitrogen? Yes, students, fixation of atmospheric nitrogen. कन्वर्जन ऑफ नाइट्रोजन टू कंपाउंड्स. ओके 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 ओके. तो जो हमारा फ्री एटमॉस्फेरिक नाइट्रोजन है बेसिकली, है ना, तो द फ्री एटमॉस्फेरिक नाइट्रोजन, इसको जब कन्वर्ट किया जाता है इनटू यूजफुल कंपाउंड जिसे हम लोग यूज कर सकते हैं. ओके, सो यूजफुल नाइट्रोजनस कंपाउंड्स, इसे हम लोग क्या बोलेंगे? वी विल कॉल इट एज द फिक्सेशन ऑफ एटमॉस्फेरिक नाइट्रोजन. एंड स्टूडेंट्स, एज फार एज आई नो, आई एम नॉट वेरी श्योर, लेकिन ये क्वेश्चन जो था हमारे सैंपल पेपर में भी था. Okay, so these questions are very important. Okay, all right. Next is laboratory preparation. If I talk about laboratory preparation by Rhizobium bacteria, correct. So if I talk about the preparation, we are taking either sodium nitrate or potassium nitrate, okay, and we make it to react with sulfuric acid. Okay, तो हमें क्या मिल रहा है? लेट्स सपोज वी आर टेकिंग पोटेशियम नाइट्रेट, वी आर टेकिंग कंसंट्रेटेड सल्फ्यूरिक एसिड, और जो हमारा टेम्परेचर है इट इज मेंटेन बिलो 200 डिग्री सेल्सियस. ओके, टेम्परेचर को 200 डिग्री सेल्सियस से कम क्यों रखते? बेसिकली बिकॉज जो हमारा फॉर्मेशन होता है दैट इज सोडियम सल्फेट और पोटेशियम सल्फेट, वो एक हार्ड लेयर बना देगा over this temperature, and you know it is difficult to remove that. Okay, and of course the apparatus भी damage होता है, हमारा fuel भी waste होता है, right? So that is the reason. तो क्या बन रहा है हमारे पास? potassium bisulfate, okay, and plus nitric acid. Correct? Okay, now talking about this nitric acid, if you have seen the commercial nitric acid, वो हमारा जो bottles में available होता है, just a minute, is yellow. Any reason for this? जो nitric acid होता है जो commercially available होता है, it is a bit yellow in color. What's the reason? हाँ जी, what's the reason that it is yellow in color? Correct, correct, correct. Impurities. There's one big reason. So the big reason is that because of dissolved nitrogen dioxide, है ना? तो जो हमारी nitrogen dioxide होती है वो dissolved होती है, and that is why the commercial acid it is yellow in color. Correct? So it is yellow cause of decomposition. तो जो हमारा nitric acid है वो by the time time के साथ it decomposes, it forms the nitrogen dioxide, and that gives the yellow color. समझ में आया सभी को? So is it clear up till here, students? Next questions आते हैं on the preparation of nitric acid as give reason question. How? Why do we use all glass apparatus? Why is all glass apparatus used? करेक्ट, क्योंकि जो हमारे वेपर्स होते हैं नाइट्रिक एसिड के वो बड़ा अटैक कर देते हैं रबर और कोक. ओके, नेक्स्ट इज HNO3 बनाने के लिए हमने यूज किया H2SO4. HCl क्यों नहीं यूज किया? सो HCl इज नॉट यूज्ड. व्हाई? बिकॉज HCl इज वोलेटाइल. और जो हमारे नाइट्रिक एसिड के वेपर्स होंगे उसमें HCl भी पहुंच जाएगा. So that is the reason. Okay. Next is, अच्छा, before moving forward, I think someone asked me Telegram channels link. तो this is my Telegram channels link dear. Okay, तो ये आप लोग join कर सकते हैं. Okay, and you will be getting this link in the description box also. Okay, तो आप लोग उसको join कर सकते हैं. Okay, you can join me on my Unacademy profile also. Okay, so that so that you can get the link of the classes and everything else. Okay, हाँ जी. Next is Unacademy free special class feature. So what is Unacademy's free special class? Basically ये जो है these are the special classes absolutely free of cost. You just need to have Unacademy learner app and you can attend these classes. Okay, यहाँ हमारा live real time interaction होता है. Okay, you can ask the questions. We are having question tab. You can attach the image of your question. Then we are also having live poll options. Okay, so these are the things, and you can get all the amazing things such as doubt clearing session, your mentorship and guidance, study material, live test, etc. by subscribing for Plus. How to subscribe? You can select any duration as per your convenience, 3 month, 12 month, 36, 48. You can use my code and then you can go for subscription. अभी बात आता है मैन्युफैक्चरिंग ऑफ नाइट्रिक एसिड. What is the process used? Which process is used? Anyone? नाइट्रिक एसिड प्रिपरेशन के लिए कौन सा प्रोसेस हम लोग यूज करेंगे? Correct Divya. So it is Oswald's process. अभी ये जो Oswald process है बड़ा ही easy process है. You just need to remember 3 basic steps. Okay. The very first step is we are taking ammonia and it undergoes oxidation. So first step says that we are having catalytic oxidation of ammonia. यहाँ पर हम क्या कर रहे हैं? We are taking a mixture of dry air. Dry air का meaning क्या हुआ? That the air which is free from any dust particles or any impurities, right? तो उस dry air का हम लोग reaction करा रहे हैं ammonia के साथ. And what is the ratio? We are taking dry air is to ammonia in the ratio 10:1. Okay, सबसे पहले तो हम इसे compress करेंगे and then it is passed into catalytic chamber. Okay, what is a catalyst over here? It is platinum gas. Okay, and what is happening here? Ammonia, it is oxidized. Okay, the catalyst, it is platinum. The temperature is approximately kept at 800 degrees Celsius. And what do we get? We get nitric oxide, water and heat. So that is exothermic reaction. Okay. Now in the second step, what is happening? This nitric oxide, it is oxidized. Okay, so the second step is oxidation of nitric oxide. So basically what is happening, we have taken this nitric oxide, it is oxidized, and what do we get? We get nitrogen dioxide. And the third step is this nitrogen dioxide, it is absorbed in water. Right? So what is happening? This nitrogen dioxide, it is taken and then it is absorbed in water to give what? The nitric acid. Okay, and remember to balance the equations. Okay, तो ये जो nitric acid हमें मिला है, it is approximately 50% concentrated. Got it, everyone? Is it clear up till here? Yes, everyone. So Oswald's process, is it clear? Okay. So next we are having the physical properties that you should be remembering, right? So if I talk about the physical properties, this acid, it is colorless, okay, but we know that it gets a kind of yellow color uh, because of the dissolved nitrogen dioxide, okay. Then it has got a kind of suffocating smell. It is hygroscopic in nature, okay. So that is the reason why we are covering the bottle of nitric acid always, okay. And yeah, so these are some of the important things. And talking about some of the reactions, like what you need to remember is how does it react with acid or base. I'm sorry, it is already acid. How does it react with base or the carbonate or the bicarbonate or sulfide, bisulfide, etc. Okay. All right. So अभी इसके बाद आता है. Okay, is it clear up till here, students? Is everything clear? Okay. Now there is one more important thing that you need to remember. It is xanthoprotic acid. Okay. Now what is this xanthoprotic acid? Anyone? What is xanthoprotic acid with respect to HNO3? Hanji, what is xanthoprotic acid? Okay, so when this HNO3 it falls into skin, अगर nitric acid हमारी skin पे गिर जाता है, it gives a kind of, it has a corrosive action और हमारे क्या हो जाते we have kind of blisters on the skin, okay, and our skin it is turned yellow, okay. Why? Because when the HNO3 reacts with the protein of our skin, it forms the xanthoprotic acid. Is it clear, everyone? Alright, so now what are the other things that you need to remember? We need to remember about the uses, okay, of the nitric acid, such as first of all, it is used to etch the designs on the copper or brassware. Next, it is used to purify gold, okay. It is used as rocket fuel oxidant. It is used in preparation of fertilizers and aqua regia. So what is aqua regia? Yes, Anmol. Okay. What is aqua regia? Which two acids are used in aqua regia? Okay, so it's HCl and HNO3, okay, nitric acid and hydrochloric acid. उसके बाद आता है the brown ring test. So brown ring test, it is very much important for your practical examinations, right? It is used to identify the nitrate, okay, or the nitric acid, okay. Mixture of HNO3 and HCl, correct. So these were some of the important things from the nitric acid, and then we are moving on to sulfuric acid. अच्छा, there is a very important question that sulfuric acid को हम लोग बोलते हैं king of chemicals. What is the reason behind that? Why is sulfuric acid known as king of chemicals? Yes, anyone? Give reason. The sulfuric acid is known as king of chemicals. So see students, sulfuric acid, it is used by a number of industries, okay, and that is why it is known as what? It is known as the king of chemicals. Yes. Now students, it was also known as oil of vitriol in the olden times. The reason was it was obtained from heating the crystals of green vitriol. Okay. So when we heated the crystals, that is, this is the green vitriol. जब हम इसे heat करेंगे, what we get? We get the sulfuric acid. This sulfur trioxide, when it reacts, it gives us sulfuric acid. Okay. So that is why it was known as oil of vitriol. Next is talking about the manufacturing. So how is manufacturing of sulfuric acid going? Like, what is the process known as? The process for manufacturing of sulfuric acid is known as what? It is contact process. Okay. अभी बात करते हैं what are the various steps that are going in the contact process. सबसे पहले we need sulfur dioxide. So the very first step is production of sulfur dioxide. Okay. Now how we get the sulfur dioxide? Either we can get it from iron pyrites or we can get it through the Louisiana sulfur. Okay. So what is iron pyrites? It is FeS2. When it undergoes the burning or we say roasting, what do we get? We get sulfur dioxide. Our next process is by burning Louisiana sulfur. Now what is Louisiana sulfur? It is the pure sulfur, that is 99.5% pure. तो क्या कर रहे हैं? When we burn it, we get the sulfur dioxide. Okay. Now this mixture of sulfur dioxide, इसमें बहुत सारी impurities होती है and we need to clean these impurities. Why? Because if we don't clean it, तो ये हमारा जो catalyst है उसे poison कर देगी. Right? So that is why it needs to be purified before it goes into the chamber. Okay. After that, what happens? Catalytic oxidation of sulfur dioxide. अभी यहाँ पर what are the catalysts that we are using? We are using vanadium pentoxide. Okay. तो basically क्या हो रहा है? The oxidation is happening and what do we get? We get sulfur trioxide and a lot of heat. Okay. And next is this sulfur trioxide, it is absorbed in sulfuric acid. Okay. So we take sulfur trioxide, we absorb it in sulfuric acid to produce pyrosulfuric acid, which is also known as oleum. And then what is happening? This oleum, it is diluted to get sulfuric acid. So this oleum, it is diluted to get what? Sulfuric acid. Okay. Understood up till here, students? Is it clear? Okay. So अभी यहाँ पर what are some of the common things that you need to remember? The very common question that is asked is sulfur. Why don't we directly dissolve sulfur trioxide in water? because this reaction is highly exothermic, और जो हमें H2SO4 मिलता है, it is present in the form of misty droplets, जो कि absorb नहीं हो सकता है by water. Okay, and next is talking about the favorable conditions. So the first thing is that we should be having excess of oxygen. Then we should be having a good catalyst. We should be having low temperature and high pressure. Okay, so this is how the sulfuric acid is formed. Okay, so I hope that up till here everything is clear to you. Is it clear, students? Any confusion up till here? All right. So now next thing is the properties of sulfuric acid. Okay, so if I talk about the chemical properties such as the acidic property, how does it react with the non-metals, how does it react with the metals? So these are the next things that you should be learning, or you should be having a quick thorough reading. Okay, now if I talk about 100% H2SO4, okay, so it is asked that this is not acting as acid. What is the reason? The reason is because it does not ionize. Okay, and therefore it does not act as acid. Okay, so when we dissolve it in water, it forms the hydronium ion. Okay, and that is why we get the properties. If I talk about H2SO4 and dissolving it in water, what do we get? We get the ions, and these ions are responsible for the acidic properties. Correct? So I hope up till here the things are very much clear. If there is any confusion, you can let me know. Alright. So these were the things from H2SO4 which were pretty important for you to remember. Okay, so we have done all the 4 compounds, students, that is HCl, hydrogen chloride, ammonia, nitric acid and sulfuric acid. Okay, and then we have done all the important topics or important terms of metallurgy. I hope that you might have understood everything that we have covered. Students, you can join us on the special classes to have in-depth revision of all the other topics of your term 2 examinations, right? And also this is high time. You can join for the plus course to receive all the PDF material, okay, the study material, the sample papers, the sample paper solution, and the one-on-one interaction, or I would say the mentorship of your educators. Okay, so you can join us on the Telegram channel also to receive regular updates. Okay, moving on to the next, there is Emerge, which is the mock test series for final exams for grade 10 and 12. You can enroll here. Okay, so the timing is 5 PM onwards, Saturday to Tuesday. Okay, so you can go for that, and also you can enroll yourself into the all subject batch, that is the ICSE grade 9 and 10. Okay, so I hope that you might have understood everything that we have covered today. You can subscribe to the channel, you can like and share, and if you want a PDF of the session, you can join the Telegram channel to receive that. Okay, so let's meet in the next class, students. Till then, all the very best for your examinations. Keep learning, keep preparing. Thank you.